Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to part 16 for our Godot Action RPG series. In this video, we're going to be doing some of the bat's artificial intelligence, and it won't be probably all of it because it's a little bit involved to do all of the artificial intelligence for the bat, but we will be doing a good chunk of it, and we'll also be adding in a little hit effect. So let's start with the hit effect. So come into create a new scene. Do other node and do animated sprite. We'll call this hit effect. And then we'll come into our effects over here and drag up the effects.gd, and we'll find our new sprite frames and call this animate. And then click this and we'll do hit effect.png. This is obviously 1 and 2. And then select all frames, add 2 frames. And how fast is this? Probably want this at 15 as well, I'm thinking. Maybe 10. Yeah, let's try for 10. Turn off playing, make sure it's on frame 0. And then we'll save. And we'll call this hit effect. That looks good. We'll come into our hurt box. Hurtbox.tscn. We'll give this a script now and create. So we'll preload our hit effect here. Const hit effect dot preload or equals preload. We'll have to come into, we'll grab hit effect.tscn, drag it in here. And we're looking good. Gets rid of both of the quotations there. Okay, and then we'll connect our signal. So hurtbox, come up, connect on area entered. And so we can have the hurtbox determine what it wants to do when it gets hit by a hitbox, right? And we'll just say var effect equals hit effect.instance get tree, well, var main equals get tree dot current scene. We can't use the parent here dot current scene because the parent is going to be freeing itself in this case. We could use the parent's parent, but that starts to get really messy. I don't recommend doing that. Main.add child effect. Effect dot global position equals global position minus vector 2 0, 8. So basically we're giving it a little bit of an offset here. Theoretically, we could probably do that here in the hit effect, actually. We come into our offset. We do, I guess it depends. It depends on if you want your hit effect to always have an offset or not. I think let's do it though. Let's do -8 here for the offset and the hit effect. And then we'll give this a try, and then in our hurtbox script right here, we won't actually, oops, don't delete that whole thing, just get rid of this little offset bit here. We'll save and run the game, see if we can get this to work. So we should hit an enemy and see a hit effect. There we go. It's hard to tell if it's too slow or too fast. I can't really tell. This is personal preference a little bit. I might make it faster. I think I like it. I think I like the hit effect animation to be a little bit faster than that. Either way, there is one problem that comes with this, which is that now our grass has a hit effect, which we do not want. So how do we solve that problem? Well, the solution that I came up with, and there may be better ones, but you know, since we're trying to reuse the hitbox, hurtbox stuff, I came up with a kind of a one-off case where there may be situations where you want a hitbox or hurtbox that doesn't create this hit effect, right? And so in that case, we can do export bool var show hit, and we'll set this equal to true. So by default, we'll show the hit effect. And then we just say if show hit, then select all of this tab, we will show the hit effect. But, you know, this could be set to false, and that's what we'll do in our grass. We'll come into our grass, we'll click on our hurt box, and we'll uncheck show hit. And so since we export it as a bool, we get a little checkbox here in the editor, so that makes it really easy. So now we get our pretty clean solution, I think, to our one-off case of not wanting the hit effect on everything we hit, not wanting it on the grass, because we already have, I mean, the leaves chopping is enough of an effect, I think, there. And there we go. So we've done our hit effect. Let's start with the bat, come back into our bat now, and we're going to set up our state machine. So we'll use an enum again, and we'll say idle, wander, chase. Our bat's going to have three main states: idle, where it just kind of stands there, wander, where it moves around in different directions, and chase, where it's actually chasing after our player. And we'll want to set up our variable here for our state, so we'll say var state, and we'll start off in the idle state like this. And then inside of our physics process, we need to set up our match statement for our state. Match state. So this is going to be a little bit of review, which is good, honestly. We'll have idle here, pass, wander, pass, and chase, pass. Okay. Let's actually start in the chase state, like this. So inside of our idle state, we want to actually have our friction, and this will be friction for our velocity, not friction for our knockback. So we'll come into, do we have a velocity? We don't have a velocity yet, so we'll want to set up that variable as well. So come up here, we'll say var velocity equals vector 2.0. And then inside of our idle, we want to apply our friction. And this will be done with velocity equals velocity dot move toward vector 2.0. And we need to have some sort of a friction amount. What was our player's friction? 500. Our bat's going to have less here. Oh, I guess we did 200 times delta up here. So maybe we'll do something similar for this, 200 times delta. We'll see. Once again, we may end up changing that value, creating a export variable for it. In fact, let's create some export variables up here. First, we'll do acceleration. We'll set it equal to 300. And we'll do max speed. Set it equal to 50. Once again, the reason there's a discrepancy there, oh, we need var in front of these, is because of the fact that delta gets applied automatically with our move and slide. And then we'll do export var friction. We'll set this equal to 200 for now. And then we can just use friction in these scenarios so we can easily update it when we're testing these things. Okay, so we've got our friction set up. Now we need to have, inside of our idle state, we're going to have some sort of function here for looking for the player. And the way that I set this up is actually, we'll create a new function here called seek player. And for now, we'll just pass. So we want to give our bat some sort of a player detection zone, a zone in which if the player walks into that zone, the bat can detect it. Okay? But we want this player detection zone to be reusable. because we're going to have, well, I mean, in this series, we won't be making multiple enemies probably, but anybody following with this series is going to want to add their own enemies later. And when they go add their own enemies, they'll want to reuse this player detection zone. So we're going to actually create a new scene here, and we'll come into Area 2D, and we can set up our player detection zone. We'll call this player detection. And that's it. We'll just call it player detection, actually. Well, I don't know. Let's call it zone. Now this, we'll save this inside of enemies. It needs a collision shape. So let's add a new collision shape. And for the sake of this video, we're going to be doing a... And some of you actually mentioned that you can export a collision shape into here and have it be made a tool, and then set the shape for your collision manually when you give it to anything. That way you can make it any shape you want. That's actually really clever, and I think that's good on you. And I might end up adding that later in this series. I don't know for sure, because it's actually a pretty good way to do it. But to keep things simple, I don't want to go into tool mode and stuff like that yet. And so we're going to do it this way still for now. So we'll just save it like this. With our collision shape, we'll add a new script here. And inside of the script for our player detection zone right here, we'll want to set a player, and we'll set this equal to null for now. Yeah, I think that should be good. But we will use a set get. Set get. Well, we don't actually need a set get. We'll just leave it like this for now. We'll say, we'll have, what functions are we going to have here? Well, since we're using a collision detection shape here, I think we need to use a physics process. Oh, we don't even need to worry about that one yet. So here's what we'll do. We'll come into our player detection zone, and we'll do an area entered and connect here. And this will be, or actually not an area entered, we want to do a body entered. So disconnect that and do body entered. And then come in and connect body exited right here. So we're going to use these signals for when the player enters this detection zone and when the player exits this detection zone. So we can say right here, inside of here, in the entered, we can say player equals body. And then right here in the exited, we could say player equals null. So player will be set to null whenever the player is outside of our detection zone, but when they're inside of it, player will be set to the body that we collided with, which in this case is going to be the player. And how do we make sure that this is always the player? Well, we can use our collision layers. We come into here, we can say that this isn't on any particular collision layer, but it's looking towards the player's collision layer. We want to make sure that it's looking towards the collision layer of our player. Now we come into our bat, we can instance our player detection zone on the bat. We can do editable children, and inside of here, we can give it a new circle shape, and we can make this shape as big as we want for however big we want our detection zone to be for the player. You can come into visibility here. I think you could lower the alpha if you want it to be slightly not quite so drastic. You could lower the alpha in there like that too. So this is our player detection zone for now. And we can come into our bat, and inside of our seek player, we can check to see if the player, well, let's see, we need one more function actually inside of our player detection zone. We're going to create a function here called can see player. And we'll just say return player does not equal null. Okay? So here, this will return either true or false based on whether or not the player is inside of our detection zone. If player equals null, then this will return false. Wait, did I get this mixed up here? Let's see. If the logic here is a little bit weird, and I'm confused on it right now. So if player is equal to null, then this would return false. We can't see the player. Yeah. If the player does not equal null, then it returns true and we can see the player. There we go. Had to think through it a little bit there. A little bit slow at the moment. But if we come into here now in our seek player, we can just say, we can come into here, our seek player, we can say, oh, we need to get access to our player detection zone too. So come up here, do onReady var player detection zone equals player detection zone. Where'd my autocomplete go? Clear. It must be broken because we don't have anything down here. Then we'll say if player detection zone dot can see player like this, then we can, and once again, this is calling down, signaling up, right? So then we can say state equals chase. We can chase the player. We'll just say print. Well, we don't want to print here. We can, this will just change to the chase state. So then we can, inside of our idle here, we can say seek player and just call that function. Okay. Now we want to have some stuff inside of the chase state. So here's what we'll do. We'll say var player equals player detection zone dot player, right? Oops. Player. And then we can say if player does not equal null, we can move towards the player. And for now, we'll just say move, let's see, velocity equals move toward, and we want to move towards, or from, we want to, let's see, velocity dot move toward, like that. And we want to move from our current, our 2 vector is going to be our max, is going to be our max speed. Max speed. Well, our 2 vector is going to be, it's going to be the direction to the player. So in order to get the direction to the player, or the vector between us and the player, we would say player.global position minus global position. So this is going to be our, let's call it direction for now. And then we'll normalize this. Dot normalized. I'm going to have to explain this here in a bit. So then the point that we want to move to is direction times max speed. And the amount that we want to move towards that is going to be acceleration times delta. Okay. And then we need to call move. Well, then actually outside of any particular state here, I think, if I remember properly, we want to call move and slide. Yep. So we'll say velocity equals move and slide. And we'll say, wait, are we already calling move? Oh, we are calling move and slide up here with a knockback. So we'll do velocity. Okay. Velocity equals unexpected assignment statement. Move and slide velocity. Where is my unexpected assignment? That is an interesting issue to be having. Oh, it's because we didn't go back far enough. We need to come clear back here to line up with the match case here. Okay. Let's see if this actually works. Okay, it does. Wow, that went rather smoothly, all things considered. And you can see only the bat that was actually, it's just buzzing around our head now, only the bat that was actually within the collision zone. So if we turn on our visible collision shapes and run the game here, we can see that only the bat, wow, it's still really transparent, so it's kind of hard to see. We may have gone a little bit too transparent with our alpha there. Okay. Now if we run it again, okay, yeah, you can see the player detection zones for our bats. So we could come over here and trigger that bat. Now it's chasing us too. Come down here, trigger that bat. Now they're all chasing after us. And of course, once we exit their player detection zone, well, that was interesting. We managed to exit them before. And they all line up, so there are bugs with this that we're going to be addressing in future videos, but this is a pretty good start. So then we also want our bat to actually face the direction that it's moving in. And I'm going to use its velocity for that direction. So we can just say down here, var, did we get access to our animated sprite? We haven't yet, so we'll just say onReady var sprite equals animated sprite. Okay. And then we can say, where were we? Sprite.flip h equals velocity.x is less than 0. And we probably only want to do this actually inside of our chase state for now. Like this. We'll see if that works. And now you can see that the bat properly faces us while chasing us. And we can kill them too if they get too close. Stay back. Stay back. Now it should, because it's still in the chase state, what happens here is, like, for example, if the bat's moving down here and then we move up past it and get out of its range, it's actually, it's hard to show here. It looks like it's chasing us still, but it's actually not chasing us. What it's doing is actually moving in the same direction that it used to be moving in. We're never actually switching back to our idle state here. And so we can do that inside of our chase state by just saying else, if the player is null, then state equals idle. And this is a kind of a quick fix for what we're doing here. But this should fix it so that the player, or so that the bat, if it comes outside of our range, let's get rid of these two real quick. If the bat comes outside of our range, it should stop. If we go outside of the detection range. You can see that now. And the reason it stops is because we switch back to the idle state and then we get our friction being applied right here again, because we don't actually apply friction in the chase state. We only apply it right here in the idle state. So let's talk about this section right here. I want to go over this real quick before I end the video. I think this is a good spot to stop though. But so when we're getting this right here, how does this math work, right? Let's talk about the vector math here, because it is a little bit weird. So we've got our grid, okay? And our bat is right here and our player is right here. So when we do the, oops, wrong window there. When we do the player position minus our global position, what we're saying is take the X and Y coordinate of our player right here and subtract that from the X and Y coordinate of our bat right here. Okay, so X and Y of the bat. So let's say, for example, that our player is at position 5 in the X and 4 in the Y, okay? And let's say, for the sake of example, that our bat is 2 in the X and 1 in the Y, okay? So what does that look like? Well, we're going to get 5 minus 2, okay? Because our player minus that, so we'll get 3, and then we'll get 4 minus 1, which will also be 3. And you can see that the distance between the bat and the player is 3 in the X, 1, 2, 3, and 3 in the Y, 1, 2, 3, okay? So that's a little bit sloppy there, but you get the idea. So let's, 2 and 1. So yeah, the difference between them is 3 and 3. So we're getting the difference between the two, but we don't actually want to move at a speed of 3 and 3, because then we would jump clear to the player instantly, right? Because that would get us to the player's position instantly. We actually want to move at the speed of our max speed. So we first normalize this, which would then get us, you know, remember how normalizing works. If you draw a circle around that and then you have your vector, then it cuts off that vector at this point, giving us a value of with a length of 1 here. This length is 1. So then once we normalize it, then we're able to multiply that by our max speed and move by whatever our max speed amount is. So that's what we're doing here. So you can see here we get, this gets us the difference in, like the difference in position between our player and our bat. And then we normalize that difference so that it's a length of 1. And then we multiply that difference by our max speed. I'm not sure that direction's the right variable name for this. That's not really a good variable name for this, because it's not like a direction of like 80, like a 90, 270, 360 or whatever. It's not like a, you know, an angle. So I'm not sure that direction's the best one, but we'll leave it at that for now. This is a pretty good start to our BATS AI. I've got some more stuff that we can do to improve on it, and we'll be doing that in later videos. But I like how this has gone so far. And so hopefully you guys learned something and enjoyed this. Once again, this video was made possible by my 1-Bit Godot Kickstarter backers. If you enjoyed it, give it a like, subscribe to my channel, and if you have any questions, let me know in the comments below, and I will talk to you all later.